Well, friends, welcome back to my YouTube channel, Unique Learning Process. So, today my topic will be different from assignment problem. The topic is transportation problem. This is again very important problem to be discussed and to be understood. So, what is transportation problem? As the word applies, transport means shifting from one place to another. And here the problem is of shifting various homogeneous goods from the place where these are manufactured, means supply is available, or to the place where demand is there, requirement is there. So transportation, we have such type of matrix. It is sometimes known as cost matrix, distance matrix, time matrix, which is to be minimized. But in transportation problem, as in the assignment problem, we say the assignment problem is not balanced because for assignment problem, number of rows must be equal to number of columns. But here, this is not the case. Here, number of rows, as in this case, are 3 and number of columns are 5. So, it's not unbalanced problem. For number 1, in order to see that this transportation problem is balanced one, we have to see that the demand must be equal to supply. As in economics, the term used is demand must be equal to supply, or the requirements must be equal to the supply or availability. So, if this is given, see these figures put in the square is known as the cost elements. Cost elements, this is first row, second row, third row, first column, second row, third column, second column. Say for example R is third row, fourth column, D is fourth column, R is, this is the cost of third row, fourth column. So that is very easy to understand. So problem is to supply, is to allocate the various elements given as per the demand. I have taken this case as of factories, say PQR factories, and production at factory P is 60 units and Q at 35 and R is 40, and depots, say at A demand is 22, 45, 20 in units. In order to see that whether the transportation problem is a balanced one or not, you have to see this. Total demand 135 is equal to total supply 135. So there is no question of rows and columns equal. It's a question of demand and supply. Total demand, it may be any. Here it may be 6 rows or 4 rows, 3 columns or 4 columns or 5 columns. But demand must be equal to supply. If it is not there, then it is unbalanced transportation problem. Before proceeding further, before solving the problem, you have to make it sure that the problem is balanced one. If the problem is not balanced one, then make it balanced. For example, demand is more, here 145, 40 units, 150 units, and supply is less. Then we have to create dummy supply. Supply over here with 0, 0 element. And if the supply is more, say 160 and demand is 135, then you have to create dummy demand. Creating dummy demand, you have to add a dummy column, and for creating dummy supply, you have to add a dummy row. That we will learn when solve the numerical. But before going further, demand must be equal to supply. So in this case, it is a balanced transportation problem. then we can proceed further. And this balanced transportation problem, method of solving. Method of solving. Method or technique of solving. There are three methods or three techniques to solve. What we want to solve? We want to justify the various demand and supply. We have to pick up the supply and satisfy the demands. So for that there are three methods. In this chapter only three methods are there. So number one is, let me write down, number one is northwest corner method, NWCM, northwest corner CM, NWCM. Second method is least cost entry method, LCEM. This is also known as matrix minima method. Metric minima method. And third is Vogel's approximation method, VAM, or Vogel approximation method, or unit penalty method. So we will take one by one with example. I will let you know the steps theoretically as well as steps to be followed numerically. Here we will take one by one method. Secondly, before going to solve this given numerical, let us understand what is the solution in transportation problem. One solution is known as feasible solution. Feasible solution, FS. We are to satisfy demands at all the depots, and we are to consume all the supply at various factories. If we could help it, if our allocations or assignments are made in such a way that assignments made are positive and they satisfy all the constraints of demand and supply, all the constraints of availability and requirements. This is also known as demand means availability, this requirement, and this is availability. These two terms are likely to be used in almost all the numericals. Then when the allocations are positive, say number of allocations are n, and allocations are positive, and allocation is positive and satisfy all the constraints constraints means limitations, all the constraints or limitations all the constraints, limitations and of demand and supply, then our solution is known as feasible, possible, likely to be taken up. That is the FS, feasible solution in transportation problems. The constraints, what are the constraints? In factory P, production is 60 only. In say depot, at depot B, demand is 45 only. We have to satisfy the demand of B, we have to pick all the units of 40 and say supply, we have to meet the demand at D, here D 18 only. So this is the constraints. This is known as keeping intact the demand and supply. Keeping intact of demand and supply. We cannot increase or decrease the supply. We cannot increase or decrease the demand. That is the case. Second is basic feasible solution, BFS. Basic feasible solution means when the number of allocations, say n, number of allocations nr is equal to number of rows plus number of column minus 1. Number, this n is a number of allocations or assignments and r is the number of rows, c is the number of columns. Say there are 3 rows and 5 columns. 3 plus 1, 5 minus 1 means 7 should be n. N should be the number of allocations. So this is the basic feasible solution. Third is optimum solution. Optimal solution. OS, optimum solution is the ultimate solution when the cost cannot be further decreased. So means we have to get the optimum solution. That is the main objective of operational research is to find the optimum answer to the different problems. So let's now start this first method, and this method is known as northwest corner method. We know this is in the matrix form, number of rows and number of columns. These are known as cell, first row, first column. Say if I put over here, this is a second row, third column. C is the cost of IAJ. I is the number of row and J is the number of column. CIJ, C is the cost. So CIJ we denote cost of ith row and jth column. So this northwest, first method is northwest corner method. So this method suggests that you start from the first cell. This is the northwest corner. First cell means first row, first column. This is the technique, as its name suggests. Northwest corner means first cell, first row, first column. Start from here and allocate as many possible units, maximum possible units which you can. So allocation is to be made as maximum possible units, keeping intact the demand and supply. So here demand is 22, supply is 60, so maximum you can allocate 22. This is the starting of this method. Start from first cell, first row, first column, and proceed in the row wise. Now here demand is 45 and here 60, 18 are required to fulfill the supply, so we can add 18 over here. Now 18 can be added to make it not 18, sorry, it must be 38. 22 here, 38 here, which can be, demand is there, but not more than 38. So again proceed further, but we can't proceed further as in the same row because 60 is over. Here 22 has been allotted, now 45. Now you have to come to second row. Here only 7 can be allocated because you have to satisfy all demand and supply. 7, 38, 7, 45. Next, move in the same row. Here it should be 20. So 20 is demand, and then 20 or 7, 27. So 8 can be like this. 18 demand for 35 supply. Then here further allocation is not possible. Then come to his here 8 has been done, say 10. And now 18 is there, now 30. 30 units satisfy 30 demand and 40 supply. Yes, please. Starting from the first row, first column, first cell, allocate as much as possible, maximum, which satisfy all the demands and supply, then keeping in view the constraints. These are the constraints of demand and supply. And further move in the row wise, then you can immediately judge your as per judgment how much is left and from where it is to be taken. Now total cost will be 4 into 22 plus 1 into 38 plus 3 into 7 plus 2 into 20 plus 2 into 8 plus 4 into 10 plus 4 into 30. 4 into 30. So this is equal to 88 plus 38 plus 21 plus 40 plus 16 plus 40 plus 120. So this is equal to 8, 8, 16, 17, 23, 2, 4, 4, 8, 9, 13, 15, 18, 26, 2, 2 or 3, 1. So total cost is 363 rupees. If we follow this method, but there are other methods also. We have to check now. Total 3 methods are there. Which is the best one? Which method is to be applied, that we will see. And second method is least cost entry method. Least cost entry method, LCEM, also known as matrix matrix minima.